In this problem we have an electric heater that runs at a given power and voltage, and we have to answer a series of questions. First question is, what's the resistance of the heating element? So it's given that it's a 540 watt power and it's operating at 120 volts. So we've got these three equations for power. It's IV, I squared R, or V squared over R. And we want to pick the one that makes sense. So for this problem, we're given power, we're given voltage, and we're trying to find resistance. So we want to take V squared over R. That means that R is equal to V squared over the power. And in this case, we have 120 squared over 540, or 26.7 ohms. In part B, they're asking for the current. So now I would choose power equals IV, or I is equal to P over V, 540 over 120, 4.5 amps. For part C, they're telling us the voltage is going to drop to 110 volts, and they want to know what the power is. So I would use power is V squared over R. V drops to 110 now. The resistance didn't change, and so the new power is 453 watts. In part D, they're saying that we didn't take into account everything in part C. We assume that when the voltage dropped to 110, the resistance stayed the same, and we calculated the power. But in actuality, when the voltage drops, the resistor cools off a little bit, and so the resistance will change a little bit, and they want to know what happens. So if R actually drops a little bit as the temperature drops, then what happens to the power? So let's take a look. Power is V squared over R, and the voltage was 110, and we used 26.7 for the resistance, but really what happens is this thing cools down, the resistance also cools down. So if the resistance gets smaller, then the power is going to be bigger. So the power will be greater than 453 watts if we take into account temperature effects.